up where the 3.4 notes part 1 ended. So this here is going to be using synthetic division to divide. Is going to be familiar with both situations and both methods for dividing. Over here, when we're divided by like x squared values, expressions, we need long division. It's more difficult to do synthetic division here. But synthetic division can be usually a little bit faster and more efficient in many cases. So first up, it works best when you're dividing by a binomial like this here, like x minus 3, if we're dividing by like x plus 5, x plus 10, whatever you're doing there. So it tends to work better with just x to the first power. Okay, so notice they kind of set this up here. Here's what it would look like with long division. So we want to set this up for synthetic. Here's how it would look. All right, first thing is over on the side, we put what x is equal to. So notice I'm dividing by x minus 3, set that equal to 0, move your 3. So really what we're talking about is x equals 3. That's what's going to go on the outside here. So we're going to put a little 3 in a little box. The 2, negative 7, 0, negative 4 are the coefficients from the problem. So if I go back to my division problem here, my polynomial, I have 2x cubed, so I'm going to just take down the coefficient 2. I'm going to put down the coefficient negative 7. There's not an x to the first term, so they had to do a placeholder here in the long division. We would also use a placeholder and do a 0 here as well. And then the constant was a negative 4. So now, one reason people like this better is because there's no variables. You know, there's only numbers. So for many people, this seems a little bit easier to work with. The first thing is your 2, whatever's first, is just going to drop down. So there's a 2. To create the next number here, we're going to multiply. So you multiply these outside numbers together to make the next thing. Where's my undo button? Where it, there it goes. There we go. So 3 times 2 would make a 6, for example, and then we can combine those together. Always add your columns. Negative 7 plus 6 makes negative 1. And then you continue the pattern. Multiply the outside. 3 times negative 1 makes the next number, and so on. I'm going to do it on the next slide where there's, these are trying to show you where all the numbers come from, so less cluttered here. So here's what it looks like. We bring down the 2. 3 times 2 is a 6. Add your columns, so negative 7 plus 6 is negative 1. Multiply again, 3 times negative 1 is negative 3. Add your column, 0 minus 3 is still negative 3. 3 times negative 3 is negative 9. Combine these together, you get negative 13. That's actually the last box. I was just kind of like the last number I was just box off. That's your remainder. Okay. So here's what happens. Those last numbers there, those actually become your answer. So with long division, you have your answer there. Here we do the same thing. We take this, it'd be a 2x squared. It's always going to be 1 power lower because we had an x cubed. We're dividing by x, so my answer should be an x squared. So this gives you my answer, 2x squared minus 1x minus 3, and then you just put minus 13 over x minus 3. That's how we talk about how to write your remainder when we're doing these. If you did long division with this problem, you would get the same exact answer here. All right. Let's try that again. So here's another example. So first things first, I have x minus 1, so I put what x is equal to, so that would be x equals a positive 1. I would add the 1 over. My numbers are going to be a 3, but they don't have the x squared term, so I'm going to put a placeholder, 0, then negative 5, then 10. Let's work this out. Okay, 3 drops down, 1 times 3 is 3. Add your column, 0 plus 3 is 3. Multiply outside, 1 times 3 is 3. Add your column, negative 5 plus 3 is negative 2. Multiply again, 1 times negative 2 is negative 2. Add this column, and the last number is always your remainder. Okay? So we'd end up with an answer like this. This would be 1 power lower, so we had an x cubed, so 3x squared plus 3x minus 2 plus 8 over the x minus 1. So, I don't know, I think some people would realize that this is a little bit smoother and faster. Like, I mean, this is much easier than having all those variables in place, but some people prefer long division, and that's okay too. Here's a couple other tips we can do with this. So, for example, let's take this polynomial. Let's do our synthetic division with, we're dividing by x plus 5. So when I set it up, I'm just going to get rid of this. It'll be a negative 5 over here. So I put the 1, the 10, the 29, 24, no missing values here. Did the synthetic division, feel free to pause and try it out yourself. Here's all the numbers you should get. The last answer there is a 4. That's my remainder. What I also want to just try is, what if I just plugged in, p negative 5? This is saying, hey, I got my p function, p of x. What if I just replace all the x's with negative 5? So I just went in here, and everywhere there was an x, I put negative 5. Now this one here, I definitely went to my calculator and I typed all that in, and I get an answer of 4. So the connection here is that remainder that we ended up with was 4. It's the same as if I just plugged in -5. So this is not something you have to know for like the quiz or the final or anything like that, but it's kind of a nice useful trick. This here I could do really quickly and easily without a calculator, and I have numbers that I can deal with easily. Here doing this, -5 third plus 10 times -5 squared, these are very large numbers and I pretty much need a calculator to do that. But your remainder is the same as if I just plug that number in for x. So it's kind of nice to know. So if I was like plugging in, I just do the synthetic division instead of all that plugging in and needing a calculator. So it's nice to know. Here just kind of goes through the remainder theorem is basically just stating that we're allowed to do that. Like here would be like a useful example. So for example, you've got these tortoises, it's modeled by this equation, and X is the year since 2015. Use our remainder theorem to estimate the population in 2023. Well, that is 8 years later, so my value is 8 for X. So I could plug in 8, it's all in here, but I mean -8 and then Q plus 6 times 8 squared plus 12 times 8. I'm not going to need a calculator for that. Those are very big numbers. Or I just do the synthetic division with 8. I mean, this doesn't require much work at all. Bring down -1. 8 times -1 is -8. 6 minus 8 is -2. Multiply to get -16. 12 minus 16 is -4. Multiply again, -32. And yeah, we have a large number here, but still not that hard to do. And I get 293. It's the same as if I just took 8 and plugged in for all those x's. Probably a little bit faster, more efficient to do. So it's kind of just a nice little trick. Our last idea, the bigger idea here is something a factor? Well, let's go and do our synthetic division here. We're trying to divide by x minus 6. It's only going to be a factor as if it divides in evenly. That means the remainder has to be 0. So if you do your synthetic division here, I'm going to use 6 because it's x minus 6 here, so x equals 6. When I do the synthetic division, and feel free to pause, try it yourself. When I do all the work, the last number is 0, so my remainder is 0. So since the remainder is 0, x minus 6 is a factor because it divides in evenly. The other way to do it is method 2 is direct substitution. So once again, I would just plug in 6 in for all of the x's and simplify. This simplifies to 0, the same as my remainder, so that tells me, oh yeah, it would have to divide in evenly because when I plug it in, I just get 0. All right, still I think synthetic division is a little bit faster and I don't even need a calculator. Here's one more example for you to try out. So we've got this here, polynomial is x plus 3 a factor. So I want to do the division, feel free to pause, try it yourself. Here's what happens. Remember, I'm using -3 because I have x plus 3. I put my coefficient. Don't forget you're missing x to the 4th, so there's a 0 there. And when you do all of this synthetic division, the last number is -21. That's your remainder, so therefore, x plus 3 is not a factor since the remainder is not 0. All right. Feel free to try out these other 2 examples if you'd like to, and I'll check your answers in class. And that brings us to the end, and attempt the practice on the next few pages, and we'll go over any questions together.